Hey, hello everyone. Right, we're the wireless walkers. So we walk out in the wild, we walk through the Wi-Fi, and we see the weirdness.
Yeah, armed with our Echo House Sidekick 2s, we get the privilege of going to a load of customer sites in various verticals and exploring the weird and wonderful world of wireless, right? So, we've each got an interesting story that we're really excited to share with you of the weird and wonderful world of wireless walking. Matt, I heard you were at site the other day.
I was indeed, yeah. So I'm Matt Smith. I think Matt Starling has introduced me today, and he's also the reason I need my surname. So thanks very much for that. We used to spend a lot of time together on site, and don't believe what he said, he never carried any of the survey equipment. So I was on site quite recently, and it's something that we experience quite a bit. We get called to site, and if you don't recognize this, I've got some other pictures of us. That's us in the wild carrying out surveys. So sometimes a client may send up a bat signal or use email or send us a message saying, help, our Wi-Fi isn't performing how we expect. So we go to site armed with our sidekicks, carry out some tests and see if we can identify what the problems are for them. And that happened very recently. I got a message saying, why isn't my Wi-Fi working? Ooh, it's something we all love to hear. And thankfully, through the tools we have, we're often able to help them identify it. So the first thing we do is we go on site, we walk and we talk with them, and we carry out a Wi-Fi scan. So we did just that. And then after the survey was done, I was looking at my 5 gigahertz, and I was thinking, not bad, right, chaps?
Looks pretty good to me, yeah.
Looks good. Pretty clean.
Yeah, a little bit of weird Wi-Fi, but otherwise looking pretty good. So job done, I can go home, everything is good. No? No. So it made me think, why is their Wi-Fi not working? If I think it looks good and the data tells me it looks good, why might it not be working? So I was thinking back to things I've learned, things I've heard at design days like this, and it made me think about this one from the Wireless LAN Professionals, the Green Diamond. Thank you very much. And it tells us that the Wi-Fi isn't really in control when it comes to things like roaming decisions. A lot of the time, the end device may make the final decision. So I was on site, I asked the client, by any chance, is your corporate network on 5 gig and 2.4 gig? And they said yes. So it made me rephrase my question from why isn't my Wi-Fi working to why do I have poor performance on 2.4? Anything you can spot there, chaps?
Pretty busy.
Yeah, someone didn't get the memo about the channel plan, did they?
No.
Is that actually a device on every single channel there?
Every single channel occupied. So they've done their channel plan perfectly. No? No. So we've got a wireless point on every single channel, plenty of overlap. We can see on that side there using 5, 4, and 3, and the rest of them. So what's going on there? So we're on site, we're going to do a little bit more digging, use our survey tools, see if we can find the culprits. So as we were going around, we went into a few of the meeting rooms, and I started spotting these things on the wall. These little pesky friends happen to be like room occupancy sensors, temperature sensors, and they all communicate back to a hub or back to each other over 2.4.
Oh, right. So did you actually manage to spot these while you're on site and kind of resolve the whole matter? And
Yeah, job done.
Nice
Everyone
one.
goes home happy, drinks on Dan.
Lovely, lovely. So, I mean, my story is not quite so favourable. So I wasn't able to solve it while on site, and it meant that I had to take my work home with me and start running through the packet captures, as we all love to do of a weekend, right? So
Good Friday night.
I'm running through this, and I kind of one of the main things I look for when I'm kind of looking for that needle in the haystack is I start with filtering on retries. So obviously, lots of retries can indicate a poor performing network. So I start with those, and I'm kind of looking through like how many, how much percentage, and then that's when I notice these deauthentication packets. And I'm thinking, that doesn't seem right. I'm sure, I mean, they do exist within 802.11. They do have a good, proper function, but I'm sure there's not supposed to be so many. So I filtered by that packet type, the deauthentication packet type, and that's when I saw that there were many, many, many of them, and many actually broadcast deauthentication packet. So instead of an AP saying to a client, okay, your session has timed out, you need to leave the network nicely, it's basically saying, everyone, just leave. And that doesn't seem a positive thing to do on a Wi-Fi network. So I was confused. I was thinking, right, is this just weird? Am I seeing something that is normal, or is this odd? Right, so I reached out to the community. I reached out to the UK Wi-Fi guys Slack community. I should say there's also an Ekahau Slack community as well for asking these sort of questions. So I reached out and I said, I've got these deauthentication packets and they look weird. Can somebody just confirm, is this weird, or am I, just seeing something normal? So people started responding. A guy called Andy came in and he said, reboot the AP, which is, a great suggestion. So I kind of reaffirmed, is this weird? Because that's what I want to know. Is this weird? Luckily, Mark jumped in and was like, yes, it's weird. I wouldn't expect to see that. So that was a great piece of information. Other people jumped in and they sort of said, it could be a whip system. They genuinely deauthenticate some SSIDs, if they see them as being rogue. So rogue containment could be genuine. Andy pops back in and he points out that it's multiple APs that are doing this. So it's Extreme, it's Meraki, it's various others. And also that it's different RSSI levels, so potentially from different sources. So, I'm almost more confused than I was. So, in summary, it's definitely weird. It could be a WIPS. It's multiple APs and potentially multiple locations. So, I go back to the packet capture. Another lovely weekend looking at, packet captures. So this time, I'm kind of trying to work out, okay, what are the sources? Where is it coming from? And I kind of see a pattern. It is mostly the same MAC addresses that you see, as well as, so we've got our Extreme, we've got our Meraki, and then there's an 8A, there's a 2E. So there's definitely a pattern. And then one more thing I notice is the sequence number. So every single one of these is giving a sequence number of 0. So a little bit of context, obviously the sequence, when an AP sends out frames over the air, they can bounce around and take different paths, and they can arrive in different orders. So the sequence number helps the receiver understand what order they should be in. So this can be a number between 0 and 4096. So is it just pot luck that I'm always getting the 0 number? I mean, that's like a 1 in 4,000 chance. So, or is there something else going on here? So I'm starting to think that this was genuinely a nefarious device.
It really is a perplexing packet capture, isn't it? Did you find out what device or devices were at the bottom of this?
Well, unfortunately not. So, I mean, I've got a theory what it might be. So I kind of, so next to the client site, there was a college. So I kind of reckon maybe they've got an ICT course that does ethical hacking, perhaps. And they create these devices because what these are doing is, rather than having a conversation over Wi-Fi, they're just shouting, deauthenticate, deauthenticate. They're not playing the game. It's weird.
Yeah, but your anonymous contributor who said the different RSSIs, surely that implies multiple sources are coming in.
Yeah. Well, not necessarily, no. So, I mean, what it could be, right? So I'm receiving on 1 and 11, right? But that might not necessarily be that they're transmitted on 1 and 11, right? Because we saw on your one with the overlap of 2.4.
Yeah.
So it could be that some are transmitted on 8, so that would be a lower level on 11, and then if they're transmitted on 10, that would be a high level because of the shape.
Oh, yeah.
Of the, so it could be.
It sounds like you had a really good, fun few weekends. Right? Yeah, you sound like great at a party, right? Yeah, obviously we've had Matt on site using the spectrum analyzer that's built into Ekahau to come to the bottom of the issues, and then Ashley, being fun, right? So I had one the other day where it was a client raised the alarm bells and they were like, we're having some major issues with the wireless. I said, no worries, guys, right? So we'll go to site and we can do an initial site survey. I said, no worry, no, we've done it. We've done the site survey already. And, when using the Ekahau, there's some amazing tools where you can't really mess up a site survey, right? It's pretty self-explanatory. And I pose to you, the audience as well, is this a good survey? So this is what I was presented with. Looks good, right? It's almost like a textbook site survey. Double thumbs. So, looking a little bit at it, I checked the scale. It looked good. There was no 15-meter doors or crazy long tables. We've surveyed the full floor here, the person surveyed the full floor, including the meeting rooms. And meeting rooms often you don't get access to because obviously this is a live office, hopefully at the busiest day. Yeah. We also have labels on there to help those that don't get to go to site or if they find anything interesting while they're walking around.
He's obviously taken his time over that. That is
it takes ages to add the labels, right?
Yeah.
He's really taken his time.
Might be missing.
And then, the APs have been accurately placed on the map. It's kind of where we would expect to see them. And then, a nice clean survey path, as Matt said earlier. We're not going over desks or going out of brickwork and then phasing in through a window. It looks quite reasonable. So I would say a good survey, right? But first impressions can be a bit misleading with this. So by default, Ekahau sets the accuracy level to 3 meters to help kind of fill in some of the blanks. But we can reduce that to 2 meters. And this is where it gets quite interesting. So this was before, and this was the 3-meter accuracy. And then if we phase over to 2 meters, we can start to see some gaps appearing. Notably, and we're going to focus in on the top left here, and we can see that there's some gaps around the top window sort of area, which isn't too big of a deal. There may be a plant or a cabinet in the way we couldn't get that close to the window, no biggie. But in the middle of the survey path, I think's a little bit interesting.
Is that like a big gap of no data right next to a data point?
Yeah, so the green lines are where the path is, and you would expect to see data points along that path, and we wouldn't expect to see a massive hole in the middle of it. It's not giving me much faith at the moment, but Ekahau's really quite good, and we can enhance the survey. So we can use the inspector mode, and it allows us to see the individual data points that were captured during the survey. So flipping over to inspector mode, and we get greeted with loads of green dots. Amazing. And it looks not too bad, apart from maybe a meeting room or two. And each of these green dots are the data that's being captured, right? So the more dots we have, the more data we have, the better the survey, the more we can use it to troubleshoot, but also help inform our future designs as well. And each of these dots takes about 2 seconds to capture. So if you go really fast, that's kind of how you end up with big holes in your survey. So looking back at one of the meeting rooms, there's not much data going on there as well, is there really? So if you imagine how fast you run, or you don't run during a survey though, do you? You walk at about a meter per second through the hall. And if you had a can of open Pringles, you would be safe, right? The crisps wouldn't go everywhere. But this person went through the meeting room, and it must have been, Pringle pandemonium in there. An absolute mess.
All over.
An absolute mess. And it's not very accurate, right? But then looking over another place in the survey file, we can see that the Pringles, he's taken a nice leisurely place, and the Pringles have kind of come out in look at that, beautiful.
Pringle perfection.
Pringle perfection, right?
That's a good host.
And this is kind of what we want to see for the entire survey file, right? But this isn't the only method we can use to check if it's a good survey or not. So each of those paths are logged in Ekahau, and we can see individually how long each of those survey paths have taken. So we can look back at that meeting room and see how long it's taken. But obviously, if you remember your GCSE maths or you're well-versed with an AI agent, you can work out how fast this has taken. So we can see it's a 685 meters of total survey path, and it's taken 7 minutes and 41 seconds to survey, which, it kind of gets out about a meter and a half per second. So it's quite quick, that is, isn't it, across the board?
That's that's a kind of, I'm running for the train, but I don't want anyone to know I'm running for the train.
Yeah. Yeah, but through a live office with people, and I saw a dog in an office the other day as well, which was interesting. It's quite optimistic. So some of the keen-eyed amongst you may have seen some of these individual paths. So zooming in on some of them, we've got some interesting ones here. So 23 meters in 11 seconds sounds good, right? So we came in this morning and we've measured the stage so we can put into perspective how fast some of these surveys were. Matt, I hear you have recently completed a marathon and you are a peak human being in athletic ability.
Well, I mean, I'm a bit caught off guard, but I do have it with me. Yeah. Thank you for mentioning that. I'll
Brilliant.
later. Yeah.
So we can see how fast these surveys are taken, right? So, Ashley, with the top watch, please. I want to see, in a real office environment, obviously you do this wireless surveys and stuff, how quickly would you typically do 10 meters?
Okay, let's go. 3, 2, 1. Lovely. 8 seconds.
Not bad.
Yeah, it's not quite there. So 10 meters, he done this in 5 seconds or thereabouts, right? So almost
That's
twice as fast. And then again, there's another interesting one, which is it works out for the stage about 5 seconds as well. So Matt, can we see, obviously you've got the best chance to hit these speeds using the Ekahau app on your phone and you're not lugging around a massive laptop. Can we try and see this pace, please?
3, 2, 1, go. Lovely.
Good.
3.6 seconds, which is a little quicker.
A little quicker.
That's nice.
He's quite fast, so he must have done the marathon in record time, right? But are you this fast? So for reference, this was a meeting room, and we can see in the floor plan it had a big table and a lot of plants. And the person done the meeting room 12 meters in 3 seconds. Sorry, Matt, but you've got to, get your pace on that. So for reference, this should be done in about 2.5 seconds from where he is now to don't hit the stage door, please.
Okay, 3, 2, 1, go. Yes, 2.4, brilliant.
So through a meeting room, that's how fast you're going. No wonder there's holes in the survey, right? But I gave you the question, right? Obviously independent. I personally don't think that this was a good survey, and I wouldn't use it to help troubleshoot maybe some of the sections, but I posed to you, the audience, was this a good survey? And obviously everyone recognises the lovely man there, of course.
Thank you very much, everyone. If you want to discuss any more Wi-Fi with us, please reach out here, but thank you for listening to us.
Thank you.